Hi students, in ray of things, problem number 9. It is a very good problem which is testing our intelligence. A ray of light strikes a horizontal plane mirror at an angle of 45 degree. At what angle should a second plane mirror be placed in order that the final reflected ray travel horizontally from the second mirror? So I have drawn a simple diagram for our understanding. You can see here AB is one incident ray and it is falling on a mirror M1. It is a plane mirror. So the angle made by the incident ray AB with the normal, that is 45 degree, is given. Okay. So naturally the angle of reflection also must be 45 degree, and the remaining angle, that is a glancing angle with the mirror, that is also 45 degree. So the reflected ray is represented by BC, from B to C. This is the reflected ray. This first reflected ray is falling on a mirror. I should place a mirror, okay, at this point, so that the second reflected ray is denoted by CD. So for the first mirror M1, the incident ray is AB and the reflected ray is BC. For the second mirror, which I have not drawn still, I have not yet drawn, but you must understand that for the second plane mirror, BC is the incident ray and CD is the final reflected ray, because they have given that the final reflected ray must travel horizontally, means parallel to the horizontal plane it should travel. So for this, in which position the mirror should be placed? So I will take see here, if it is a plane mirror, you assume this is a plane mirror, I cannot place the plane mirror in this position, is it not? Similarly, I cannot place the plane mirror in this position also. But definitely in between these two positions, somewhere I should place the plane mirror. So let us see now. I will place the plane mirror in such a position that the angle of incidence of the ray BC is equal to the angle of reflection of the ray CD. In such a position I have to draw. So approximately you see here, okay, this must be the position. So I am drawing the plane mirror like this. So the second plane mirror must be placed in this position only, M2. Have you all understood first? At this point I should draw a normal now. So from this point, if I will draw a normal like this, so this is the normal for the second plane mirror M2. So this is N dash. Okay. Suppose if this mirror M2 were not placed, suppose if I have not placed the mirror M2 here, what should have happened? The light should have traveled from B to C, then C to E. Okay, for example, I will take this path is CE. So from B, C, E, like that, it should have continued the straight line path. Since I have placed the second plane mirror M2 at this point C, the light has deviated along the path CD, which is along the horizontal. Okay, now we have to find this angle, that is M2CD. This angle I have to find out. So at what angle this should be placed? This angle M2CD I have to find out. Okay, so for that, now let us use this concept. This angle of incidence of BC is taken as theta, so that this angle of reflection, that is by the ray CD, is also theta. Okay. Now this BCE is a straight line. Therefore the total angle must be what? 180 degree. Is it not? Also you see here, this mirror M1 is kept along the horizontal, and this straight line CD is also along the horizontal, so that this plane mirror M1 and this reflected CD are parallel to each other. So if this angle is 45 degree, means then this corresponding angle, this total angle ECD must also be equal to 45 degree. Understood or not? Because corresponding angle. See here, first of all, this ECD, I will write this angle ECD is equal to 45 degree because it is a corresponding angle between the two parallel lines. Okay. Now, the angle BCE, is angle of a straight line. What that must be equal to? 180 degree. Understood? So, if I add this angle theta plus this angle theta plus 45, the total angle must be equal to how much? 180 degree. Are you understanding? Okay. Now, I will write. So, theta plus 45 is equal to 180. So 2 theta plus 45. So 2 theta is equal to 180 minus 45. 180 minus 45. So this will be equal to 135. So this is equal to 135 degree. 2 theta is equal to 135 degree. So what is theta? Therefore what must be? Theta is equal to 135 by 2. So this must be equal to 67.5 degree. This angle theta must be equal to what? 67.5 degree. Is it not? So now you look at the picture once again. We want to get the angle M2CD. M2CD only we have to find out. So this angle between the plane mirror M2, the angle between the plane mirror M2 and this normal C and dash is equal to how much? 90 degrees. That normal means 90 degree. Therefore, this angle M2CD, therefore, angle M2CD must be equal to 90 minus theta. So, this M2C n dash is 90 minus DC n dash, that is a theta. So 90 minus theta, and this is equal to what? 90 minus 67.5 degree. So this angle is equal to 22.5 degree. 22.5 degree. And this angle 22.5 degree, this angle is made with the CD. Okay. So with the horizontal, with the direction CD. That is horizontal. Okay. What are the four options you see here? Clearly the first option is correct. Is it not? Clearly 22.5 degree with the horizontal. Okay students. Therefore what is the correct option? Therefore answer, that is option A is the correct answer. So option A is the correct answer. Okay, anyhow, in this question, four options, different values are given. Is it not? Different values are given, luckily. Sometimes what will happen? 22.5 degree option will be correct, but one will be with the horizontal, one with respect to the mirror, with respect to the incident direction, like that they will give. So very clear about the answer you should be. So such problems can be easily solved when you have the practice of drawing the simple schematic diagrams. I hope you must have understood well. Fine.